This is for statistic 11.2 contingency tables. In 11.1, we do a goodness of fit test, which is one variable, one categorical variable with different categories or different choices. So in this case, that the difference between 11.1 and 11.2 is 11.1 you only have one categorical variables. They have all different categories in this case. But 11.2 we're going to do with two categorical variables. So you have two categorical variables and they all have different categories too, or different choices. So in this case, one is for goodness of fit test is only for one categorical variable. Contingency tables is for two categorical variables. In the contingency table, we are still using chi-square as same thing as goodness of fit test. But in this case, your chi-square, we have two types of tests. One is called the test of independence, and the other one is called the test of homogeneity. So it is very obvious. The question will ask you what kind of test is it. If a question is asking you for test of homogeneity, that means we want to know that your row and your column variables are independent or not. Okay, so example is, let's say that you have a contingency table here with a male and female, which is the categorical variables, and you have, let's say we have white, black, Asian, and Hispanic, different types of groups here. They are also categorical variables. So we got two categorical variables in this case. You want to figure out if the gender is independent with the ethnicity in this case. So this is how we use the test of independence here. O is the observed frequency. Again, this observed frequency usually is given in the data or you collect from the sample. So all these numbers are what we call as observed frequency. E is the expected frequency, means we expected to have that many people in such a frequency here. So like this case, 30 stands for you have 30 male who is white. 21 in this case, we have 21 female who is white. So in this case, this is the observed frequency. The expected frequency is something that is not given in the R, so you do have to calculate yourself. It's very important. I will show it to you in the first example, how do we calculate expected frequency. R in this case is a number of categories in row. So this is what we call as the row, the one that goes up, down here. So in this case, you have 4 categories for row, and C is a number of categories in the column. So this is the column that goes sideways, and in this case, we got 2 categories in the columns. So the requirement says that it has to be random selected or random sample. It has to be your frequency count has to be in two-way tables, means that this table has to be your data has to be put in a two-way table, not the raw data. And as the last one is all your the expected frequency for all the cells has to be at least 5. Okay, so the hypothesis statement is very straightforward. Either H0 is the row and column variables are independent. H1 is the row and column is dependent. So when you do your hypothesis testing, if you have p-value is less than alpha, then you will be stating that the row and column variables are dependent. If your p-value is greater than alpha, then you will be failed to reject H0, means that you will be taking the sentence of H0, means that the row and column variables are independent. Okay. To find your expected value, you take the row total times the column total divided by the grand total. What is a row total? A row total means you total up your row here. So in this case, it's 51 is your row total for this case. A column total means is this column total. So you add this one up, you get 69. And then the grand total means you total the whole thing up, which is in this case is 122. So in order for us to find the expected value for the male male who is white, so you take 69 times 51 divided by 122, and that is how you find the expected value for the male white. To find the expected value for female white, you have to do 53 times 51 divided by 122. So in this case, you have to do around 10 expected frequency here. So for each of the cell, you have to find the expected frequency, and all of this has to be at least 5 to fulfill the third requirement. The degree of freedom. The degree of freedom in this case is you take the number of rows minus 1 times the number of column minus 1. So in this case, the row we have 4, so 4 minus 1 is 3, and column is 2, 2 minus 1 is 1, so 3 times 1 is 3, so that is the degree of freedom. So your critical value in this case is the same way that you calculate your critical value for goodness of fit test in 11.1. Don't forget that your chi-square distribution is always a right tail. So you use Q chi-square 1 minus alpha degree of freedom. In order for us to calculate this using R, you have to use matrix. So in this case, how do you create matrix in R is you do X equals to matrix C, and then these are all your observed frequency, and then you tell me how many columns we have. And when you read the observed frequency, you have to read down. What do I mean by read down in this case? For example, is if I want to put this number into my R, I have to read down from the first column, and then second column, and then the third column. So in this case, my first number in this case is 30, followed by 21, 8, 7, and 3. And then 21, 15, 10, 5, and 2. So, and then after that, how many columns we have? We have 2 columns in this case. So this is how you're going to write these vectors in the matrix form. And then you just type X. This X will ensure you that your contingency table will show exactly like this. And then you just do chi-square dot test X correct equals to false. This will give us your p-value and your test statistic in chi-square. Next, we will talk about the test of homogeneity. This test of homogeneity is telling us that these two proportion have same proportion or they have different proportion. So the test of homogeneity is the same test as the test of independence. So that means that if you know how to do test of independence, you should know how to do test of homogeneity. They are the same test. The only difference here is you have a different hypothesis statement. So for test of homogeneity, the hypothesis statement says that the different population will have the same proportion of some characteristic. And for your null hypothesis is the different population have a different proportion or not the same proportion of some characteristics. And in order for us to support your null hypothesis, your p-value has to be greater than alpha. If you want to support H1, your p-value should be less than alpha. So this is the 2 types of tests we'll be doing in 11.2 contingency table, where we talk about tests of homogeneity and tests of independence. And as I told you, these 2 tests are exactly the same, except your hypothesis statement is different.